let us look into further parts. Next, searching and sorting techniques, which are the most important parts basically in the interview parts. Okay, searching. What is searching? In the name itself, to find an element or to check whether the element is present or not in your array. The best examples are linear search and binary search. What is sorting? Sorting, arranging the elements in order. It may be an ascending order or it may be a descending order. And the examples for them are bubble sort, selection sort. We will be learning about this 4 shortly. First of all, what is a linear search? Searching for an element linearly or sequentially. Suppose this is an array given, find 20. The question is find 20. First it checks in the 0 index, is it there? Not there. Next increments its index and check for that element, not there, not same. Again increment, checks for the index, not same. Again increments, checks for the index, not same. Again increment, and here you can see 20 is being found. So what it will do, it will return this index 6. That is your linear search. Very simple. Okay, searching linearly. Now let us look into the program point of view immediately. So how we are doing? First of all, linear search. In linear search, we are returning what? We are returning the index value, nothing but the index at which both your key to search and the element present are same. What is the index value? Returning the index value. What is that value? Your key, whatever the number which you want to search and the element which is present in your array are same, then we will return that index. Okay, so the first thing is enter number of elements you want. Suppose you want 5 elements, enter 5 elements. That is nothing but enter the size of your array. That's it, right? But not array. Okay, remember that is not the meaning of array, but you need to write the size which you want. And next enter each and every element, and each and every element are being scanned into your array. This is the most important point. Take the size and till that size, nothing but for each element of that size. If the size is 5, for 0th index, for 1th index, second, in that way, for each and every index, you insert the elements which you have written here. Okay, the elements which you have written here are being inserted into your array. Okay, and obviously you need to write which value you want to search, what value you want to search, or key value you want to search. Okay, scan it into a variable called as key. Now here comes the main logic. What is the main logic? Again using the for loop for the size of your array, okay, not array size is nothing but not 10. Okay, the size which you mentioned, or size you mentioned. Now simply we are saying a statement, if the key you want to search is equal to the element at index I, then say key is found at that index. Okay, key, then you can say key found at I index. We have used here I plus 1 because the first element is 0, right? So if you want to print the exact element, suppose if I take index 1, then that becomes second element, right? So if you want to print it as a second element, you can use I plus 1, or you can use I if you want only index. So here I is being incremented every time. Why? You are using a for loop till that size, nothing but checking for each and every element. You can say checking for each and every element in the array. Okay, and if it is found, go out of the loop and print the go out of the loop. Okay, go out of the loop in the sense it comes out of this, and this is a negative condition. If I is equal to n, nothing but I and n. After coming out of the loop, if the size of the array and your iteration are same, then you can say key is not found, right? That's it, right? So what I'm telling is, if you have reached till the end of the array, nothing but I will be n, right? Suppose there are 5 elements. If you have reached to the fifth place, then I is nothing but n. That means that the element is not found. This condition is not been executed. Simply you can write key is not found. This is your linear search. It is very simple. First, give the size of elements you want to store and give the elements to store that into the array A, and what key you want to search, give them, and taking a for loop from the 0th index till the nth index, till the what size of the array. You write if key and the element, array element, okay, are same, double equal to are same, then you print key is found at that index. Index is integer, right? %id and I plus 1. And you can write break, because if you don't write break, then the loop will again execute. You write break so that directly it comes out of the loop and looks for the other statements. This is about linear search. Let us compile it and run. 50 linear search. Okay, let us give a linearly elements, ordered elements. We want to search 50. Sorry, I have given wrong. 1 second. Enter number of elements. I want 6 elements. 10, 30, 40, 50, 52, and 60. 6 elements. I want to search 52. Yeah, so 52 is found at 5th place. 1, 2, 3, 4, 5. So why we have mentioned here I plus 1, I hope you got to know, okay? If you don't write I plus 1, then it will say 4. 4. 4 is nothing but somewhat it goes into some other meaning, okay? That's why we have specified there I plus 1. This is about linear search. It is a very easy searching technique. Next, binary search. What is meant by binary search? Binary search is nothing but the name itself binary, nothing but you are dividing. So binary search, however, reduces the time complexity. Suppose, let us take, right, there are two halves. The element is in either of two halves. So if I, by some condition, if I got to know the element is in either of two halves, then it will be easy to predict where the element is. Nothing but I can do it in a fastest manner. That is the theme of binary search, okay? You can check there are set of elements given 2, 5, 8, 12, 16, 23, 38, and 56, 72, 91, etc. Here the condition is search 23. So 23 is actually here. So what we are doing is we are taking three things: L, H, and M. Okay, L, H, and M. We are calculating L plus H by 2, and we are taking the M value, and based on that M value we are getting to know that where you need to search, first half or second half. Okay, so let us learn it using the code so that it makes more simpler. Binary search, as I said, you need to declare an array, and whatever the key you want to search, low, high, and mid. Low is the starting point, high is the end point, and mid is the middle point. N is your size of the array, I is your iterating variable. Scan n value. First, how many elements you want to store, you need to give, and using same like linear search. Okay, scan those elements whatever you have written into the array A. Scan the key value, which the key which you want to search. Okay, scan that as into a variable key. Now here comes the main logic. Okay, initially I'm keeping low 0 and high to be n minus 1. N is nothing but size or length of the array. Okay, low to be 0, high to be n minus 1. Okay, so you can check here, low is fixed to 0 and high is fixed to n minus 1. Let us take the size of the array is 10, right? 10 minus 1 is 9, so I is here. And also we are taking, we are running a for loop, a while loop, while low less than or equal to high. Okay, while low less than or equal to high, obviously 0 is less than 9. We are saying that mid equal to low plus high by 2. We are taking the mid value. Okay, nothing but we are taking the middle element. So what is the use of middle element? We will get to know. So if middle element is equal to key, simply say middle element is found at that index. Okay, mid is nothing but that represents your low plus I by 2 index, nothing but the middle, whatever the number you will be having, that index. And you can say directly break. And if it is not there, then what we are doing is check between key and your array of mid. Array of mid is nothing but the element, the key element and the middle indexed element. The middle indexed element is 16 and check the key. Key is nothing but you want to search 23. So what is the difference between them? 16 is less than 23. Is it true? Yes. So if it is true, then your low will get updated to mid plus 1. Nothing but low moves to here. Now you need to check only the second half. Understand? Low moves to the mid plus 1. Nothing but low moves to this position. Nothing but you need not check this half. This first half is now completed. The element will be only in this second half by that condition. Okay, and you will be checking for that element. Similarly here, low is 5, high is 9 again for middle element. Checking that middle element and the 23. Okay, between those both, and you can check that 56, nothing but the middle element is less than 23. Is it true? No, it is false. So obviously you need to change your high. High will be changing to what? Mid minus 1. Nothing but high will be now this position. Okay, now you can say by this only you can tell that this condition array of mid equal to key. Okay, here you can say that both are found. 23 is found, and at what index it is found? 5th index. Okay, I hope you understand. Low is been moved to 5 and M is been moved to 7. High was initially at its position itself 9. 9 plus 5 by 2, which is 7. This is your middle element, and again what you are doing after this statement, checking. Okay, low less than or equal to I. Yes, it is true. And again taking the mid we have taken, checking for this. No, this is not being satisfied. Checking for this, mid is less than or equal to key. 56 less than 23. No, it is false. So this else if case will not execute. Obviously this else case, high must be mid minus 1. Nothing but high will be mid minus 1. Mid minus 1 is nothing but 7 minus 1, 6. So your high will be moving to this location. Okay, high will be moving to this location. Now after that, low, high. Again the same statement comes, and finally you will be entering into a condition where your middle element will become your key. And you can say that key is found at that index, middle element, whatever the index is there at that place. So it will return 5. That is the working principle of your binary search. It is very simple binary search. Okay, just you are simply dividing it into two parts and checking whether the element is greater than the middle element or less than the middle element. If the element is greater than the middle element, then you will be checking in the right half. If the element is less than the middle element, then you will be checking in the left half. So it gives you what we say, a brief assumption that where you can check left half or right half. Okay, so that it saves your time. And let us execute it. Let us give the same values: 258, 12, 16, 20, 38. 258, sorry, I'll be giving X elements: 258, 12, 13, 23, 35. Sorry, that's it, right? 1, 2, 3, 4, 5. So I want to search 13. Fifth place. So you got at fifth place 13 is being found. This is about your binary search. Very simple, okay? Taking low, 0, high, n minus 1. Main logic where you're taking your middle and comparing your middle with your key. Initially it might be true, but this is a necessary condition because we are trying to make it to satisfy this condition, okay? Middle element to be same as key. And again, else if condition where middle less than key and low, if it is less than key, then low you change your low value, or else you change your high value. Okay, it is very clear. Next, bubble sort. Here comes the sorting techniques. What is sorting techniques? Arranging the elements in an order. Bubble sort is nothing but comparing the adjacent elements. Comparing 5 and 3. If 5, you can see that 3 is greater, 5 is greater than 3, so it must come after 3. So you just swap it. 3 comes here. Compare next. Compare next. Compare next. In that way, what you are doing, you are placing the highest element at the end. Okay, the biggest element is occupied at the right place of the final result. That clearly says that the elements are placed in a sorted manner or sorted order. Let us look into the program bubble sort, which is very simple. Taking the array of some size, I, j, iterating variable, taking a temporary variable. Okay, why we are using temporary variable is y temp to do swapping. Just now we have seen, right? We need to do swapping. First step is scanning that n value. You need to scan the number of elements and using printf statement enter those elements, and those elements are being scanned into your array A. So this is a common statement where you will be writing in your matrices or searching or sorting. Okay, and here comes the main logic. Starting from 0 until n minus 1, nothing but till last index, or you can say 1 to n, that is also correct. Those are the number of phases, and for each iteration, nothing but inside inner for loop from 0 to n minus I minus 1, n minus I minus 1, okay, n minus I minus 1. You need to take iterations in each phase. If you want the iterations in each phase, then you need to take n minus I minus 1, okay, and checking for a of j greater than a of j plus 1. Simply comparing adjacent elements. This is true, then swapping is done. Swapping is nothing but what? This is swapping using an external variable temp. Okay, using external variable temp. Simple. Just you assign the first value to temp. First value you assign to the second value, and that second value, the first value has been holded by the temp, that you need to assign to the second value. I hope it's very simple, right? Once again, I'll be saying, let us say A, B are two numbers to be swapped. So what I'm doing, I'm storing A in C and I'm storing B in A. So now A is B and if I want B to be A, I'm saying B must store C. That's it. The same story we have written here also. Okay, this is the swapping procedure, and this is the main logic. Sorted array. In order to get that sorted array, so here what we are doing, swapping is being done in the sense, obviously the elements will be sorted. So the sorted array in ascending order. To get in ascending order, you can do this. Using a for loop, we are printing the elements. Sorted array. Okay. Once again, this is an array, and this is the size of the array, having two variables, iterative variables. For I till the size of the array, and for j till the size of array minus I. Nothing but minus I for each phase. Okay, for each phase, you are comparing your a of j and a of j plus 1. Nothing but the adjacent elements. And if the first adjacent element is greater than the second, then you need to swap, because that is the largest element which must be come after the smaller element. That's why we are doing swapping, simple swap condition, where the first element is being stored in an external variable, and next the first element now stores the second element value, and the second element value will store what? The first element value. The first element value is being stored by the external variable c. So you can write that second variable value as external variable temp. Okay, you can check here condition, whatever the statements which you have written here, and printing the sorted array. Let us take an example. Suppose I want 7 elements, 50, 20, 40, 55, 63, 25, 78. You can see all elements are in sorted: 20, 25, 40, 50, 55, 63, 78. Okay, this is the sorted array in ascending order. This is all about your bubble. Okay, simple swapping the adjacent elements. This is the first iteration itself. Okay, you will be having first iteration, or you can say first phase. Next, selection sort. What is selection sort? It is an algorithm, very important algorithm, which sorts an array by repeatedly finding the minimum element from unsorted part and putting it at the beginning. Finding the minimum element and putting it at the beginning. In bubble sort, we are finding the maximum and we are moving it to the last part, right? Whereas in selection sort, we are finding the minimum element from the unsorted part and we are putting it in the beginning. But remember, it is not opposite of bubble sort. Here there is some different technique. So it maintains two subarrays, the subarray which is already sorted and the remaining subarray which is unsorted. Let us look at using a program where you can understand it clearly. Again, inside the main function, we have taken array of some size, n to be the number of elements in the array, ij, iterative variables, temp, to do swapping. So here also we will do swapping, and take min position is nothing but minimum element. Okay, every time we are checking for a minimum element to be placed at the starting of the array. The first two statements are same. Scanning, okay, enter the number of elements and scan it into a variable n. Second is scanning the array elements. It is also simple, right? You need to scan each and every element, whatever you have written here. And here comes the main logic. Till the size, okay, till the size. Okay, what you need to do is, initially you set up the first position, nothing but initially set up the 0th position as min element. Okay, min element. After that, So for every iteration, okay, whenever you enter this I iteration, you set up the 0th position element as the minimum element, and in this j starts from, so you need to check. I can say that check or compare from second element, nothing but 1th position element or 1th index element. Okay, that's why we have kept j equal to I plus 1. From second element onwards you try to check, and same till the end of the array, till the end of the array. Or you can take, why we have taken n is, you know it, less than n, or you can take less than n, less than or equal to n minus 1, and incrementing j, which is a easy condition, and checking that if the min element chosen earlier is greater than the element chosen in the loop, okay, in the loop a of j. Okay, then what you need to do, obviously the a of j will be what, minimum element is greater than the element chosen in loop, nothing but the element chosen in the loop is the smaller element. So your min pos, nothing but your min pos index, minimum value, but minimum number index will change to j, nothing but you can write j. Here only you will be dealing with indexes. And after that, what you need to do, if this condition is true, this statement gets executed. After that, the very simple thing is what, swap the I with min underscore pos element. Swapping your I is nothing but with whatever the index which you have entered and the new minimum position which you have got, that is j, you need to swap it. Swapping again, same, temp equal to a of I, a of I, a of min pos, and a of min pos to be temp. Okay, just like the bubble sort which you have taken here, right? So what we have done is here minimum position as j. So you need to understand here. Suppose let us take, right, 10, 20, 30. Okay, this is the 0th index element. Okay, this is the j, this represents j, first element is I. So we from this we can write that min pos as I is nothing but 0. Okay, min pos as 0, which represents element 10, and we are saying a of j is nothing but I plus 1, 20. So is 20 less than a of min pos, nothing but 10. Is this true? No, it is false. So the if statement will not get executed. Let us say that let us give this some 30 and 40. Is this true? Yes, it is true. So what happens? Min underscore pos is being changed to j. J is nothing but, initially it was 0, now it will become 1. That's it, right? The first index was initially the smaller element. Now comparing the first index and the second index element, you got to know that the second index, the 0th element index is the smaller element. On comparing the 0th element index with the first element index, 1th index, you got to know that the 1th index element is the greater. Okay, then what you will do, the 1th index element as what, smaller, then you simply change your min to the second index, nothing but the index 1. The same is being done here. Suppose if here is 5, then this will be changed to here. Okay, in that way, 20 less than 30, is this true? Yes, true. Min position changes to j. Sorry, I have to give it like this, right? Okay, in that way you need to give your conditions, and after that min position is being changed to the next position element, nothing but what? Now the first element and the second element are same. That's it, right? After that point of time, your first element and the second element will be almost similar. So what you are doing, you are swapping your initially whatever you have taken the ith value, you are swapping it with min pos. Okay, nothing but the minimum element. After swapping, you can place that I in your first position, nothing but the 0th index position. Similarly, the for loop runs for the further elements. Okay, let us take the set of elements, right? 20, 10, 30, 40, 50. Okay, these are the elements given to us. So for I is equal to 0, and I will be writing the indexes as well so that it makes clear, right? 0, 1, 2, 3, and 4. Sorry. These are the indexes. So for I is equal to 0, min pos is I. Min pos is I is nothing but, what can you say? I will be writing here. Min underscore pos is position is I. I is nothing but 0. For j equal to I plus 1, nothing but j is now 1. So if a of j, a of 1, nothing but this 10. If 10 is less than a of 0, nothing but 20. 10 less than 20, is this true? Yes, it is true. So what happens now? What we are doing is min underscore pos is being changed to j. J is nothing but 1. This was the least element. So obviously your min pos must become now this element, right? The same has been done here. And swapping the ith value and min pos value. Ith value and min pos value. You have changed your index here. Here what you have done? You have changed your index. But one more thing you need to do is what you need to swap the numbers. So for swapping, we are using this condition. A of I and min pos, swapping them. Min pos is now jth index, nothing but 1, and A of I is nothing but 0. Okay, 0th index element. Swapping those both is been done here. After swapping, you'll be getting in this way 10, 20, 30, 40, 50. So after this, I think there is nothing to swap, right? That's it, I think. After this for loop, if you have further, again the min pos will be changed to this element, this min pos I and checking for this, min pos is checking for this, in that way. Okay, if there is some greater min pos is greater than the next element. Okay, and here comes the end of your logic, printing the sorted array. As you know that after swapping, your array will be in a sorted order, and we are printing the same array here, printing the sorted array. Let us execute this program. 6 elements, 50, 10, 20, 30, 85. Sorry, I have given only 5 elements. Let us execute it once again. I give 6 elements, 50, 20, 10, 45, 66, 23. 10, 20, 23, 45, 50, 66. Okay, the elements are in sorted order. This is your selection sort. Simple selection sort is nothing but selecting the minimum element, swapping the indexes of minimum element with the next element if the next element is lesser than the minimum element, and after that you are swapping the actual values. First you are changing the minimum element or the minimum variables index, after that you are swapping the actual variables or actual values. That is your selection sort. Next topic is strings in C. What is string? String is a sequence of characters. Character is nothing but you will be represented in a single quotation. Strings are nothing but set of characters. And remember, string ends with a null character. #0. How you declare a string? Simple. Char is the reserved keyword, the same keyword which you use to declare the strings, but here you will be giving an array type of thing like 5. This char s of 5 is nothing but where you can space different strings, character strings. Okay. Check language ABCD. This is some initializations where you can give off. And the string functions. There are basically the most important string functions are 4, but there are many functions. But in this session, we will be learning the important and useful string functions, which are strl, len, string length, which calculates the length of a string, and string copy, nothing but it copies a string to another string, copy the string to another string variable. Okay. String comparison compares two strings. String concatenation concatenates two string. Okay. Let us look at sample program so that you can understand it, right? Remember, using this string predefined functions, you need to write this header file as well. String header file. Why we are using? Question is, answer is what? Answer is because we are using predefined string methods. What are those predefined string methods? String copy, the string concatenation, string length, string comparison. These all are what? Predefined string methods. So who will know those predefined string methods? Obviously, the C library knows. Which library? String header file library will know those predefined methods or functions. Okay. You can see this simple program where you have the main method, the first string, which is size, keeping a reserved size of 10, and the string is being named as hello, and string 2 named as world, and string 3 which is just declared. Okay. And we are taking length and n is a separate variable. We will get to know what is the use of this n. Let us do the string copy. As str3 is just declared, we can assign, or you can say we can assign or copy the string 1 value to string 3. So how you will do? Str copy of the value, the string which you want to copy to the string which you have the matter. Okay. String which is empty and a string which has matter. This str1 is being copied into str3. It is simply like assigning. Okay. And you can print string copy, and remember, for string, the format specifier is percentile s. Okay. For integer, what is the format specifier? Percentile d. For float, it is percentile f. Okay. Similarly, for string also you have, and for character it is percentile c, not ch, and for string it is percentile s. So we are printing the string 3, whether it's copied or not. To get to know about the string copy function or method, we are printing the string 3. And string concatenation. Suppose I want to concatenate string 1 and string 2. Simply you will say concatenate is nothing but adding or summing up two strings, string 1 comma string 3. So string 1 will be added to the string 2 will be added to the string 1. Remember, first one is the first, whatever the string which you specify will have the actual output. Nothing but, if you check here, string 3, string 1 is being assigned to string 3. You take string 1, string 2 is being added into string 1. Okay. And length, I want to know length of the string, strlen of string 1. Okay. Printing that length obviously will be percentile d, format specifier integer. Okay. how you will compare. So what I am doing is comparing is nothing but relational applying or checking relation. Okay, that's it, right? So here you will get to know that if the relations are comparison, both are same, true or false. Okay, you will be getting 1 or 0. So the same story comes here. String comparison of string 1 and string 3. As you know that we have copied string 1 to string 3, both are same. Both are same in the sense this strcmp is a function or a method which has some definition, and that definition will compare these both strings and return this one because both are same. Here hello and here we have copied, right? And that value is being the function definition which will return the value to the call to this function strcmp, and it will assign or it will be allocated to the variable n. That variable is being printed here. Okay, what is the value will be printed. If it is 1, yes, both are compared and both are same. Okay, 2, what happens? Okay, first one is greater than second one, third one is second one is greater than first one, in that way. Okay, check, one is being printed, and string copy str3 whatever str1 is being copied into str3, printing hello. Concatenation also same story. Okay, hello world, hello is there, world is there, hello world, and length of the str1, whatever the length you have specified earlier, it is 10, that is being printed. And finally str comparing 1 and 3, that is your string comparison. This is about using the predefined string functions, string concatenation, string length. Here specifying here we are using a separate variable len length to get the value of that length of that string, to get the value of the length of the string. And string comparison, as I said, comparing both of them. If it is both are same, true or else false, and true and false are nothing but you know it very well. Suppose if I take here instead of string 2, if I say both are comparing both of them, right? So let us say 2. Okay, string 3, copy string 2 to string 3. Let us execute it. 1 second, I need to close this. Compile and run. So you got what? -1. Nothing but both are different. So you are not get minus, you will not get 0. You will get -1. If both are different, you will get -1. That is the string comparison technique. So these are the predefined string functions where you can use in your strings. And you can check string length, which calculates the length of your string, and the copy cpy copies the string to the other part. Okay, cmp, so compares two strings, nothing but if strings are equal 0, and if first non-matching character that nothing but the first string is greater than the second string, it will print 1. Okay, and -1 if both are non-matching. If the first non-matching is lower than that of string